Welcome to DLOC Topic 8, Section 12A. I'm Kevin Laws, the Science and Operations Officer at the National Weather Service office in Birmingham, Alabama. Section 12A will cover storm-based warnings for isolated supercells. The objectives for this lesson are to issue storm-based warnings for supercells with nonlinear motions. As most of you realize, supercells are typically left or right moving, and we want to issue proper warnings to cover those deviant motions. We also want to maximize lead time and minimize false alarm area. At the end, I'll give you some general tips about issuing warnings. The first thing we need to understand is that we want to have guidelines and not rigid rules. A lot of times when folks have rigid rules, it's tough for them to think outside the box, and what I want you to understand is that every storm throughout your career is going to be a little bit different. That means every warning will be unique in some way, shape, or form. So I need you to always be adaptable and flexible, willing to change when the situation needs it to change. You're going to be successful if you correctly apply three things: the local storm environment, radar interpretation, and any storm reports. When you add those to your warnings and you're adaptable to any situation that begins unfolding, you're going to be successful. Let's go over a couple examples. This is from the April 27, 2011 super outbreak across the southeastern United States. I want to focus on this storm here in northeastern Pickens County here, just northeast of the town of Reform. Obviously this storm is in desperate need of a tornado warning. You can definitely see the beware signature here in the 0.5 reflectivity. Flipping over to the velocity, we have a nice mesocyclone and several intense actually gate-to-gate shear axes. When we first bring up WarnGen, when I issue a warning for this storm, it may look something similar to this. What we want to do is set the vertice right over top of the mesocyclone, the centroid point, and then we want to scroll the radar back in time and continue putting that centroid right over the mesocyclone. If need be, we can actually take this back some ways. Here I've taken it back almost half an hour, and I've still located that centroid right over the mesocyclone gate-to-gate couplet. But in the end, we want to bring the radar back up to real time and place that centroid back over the mesocyclone, as seen here. The next thing we want to do is hit the track button, and you'll see that it's put out a default 45-minute polygon here that looks something like this, the general motion being to the northeast. Question is, what happens if we actually issue this default polygon? Well, it looks something like this. As that supercell continued to track northeast, notice that it begins to right turn. Eventually, over the course of that warning, it's going to right turn right out of the box. In this case, that would have been a disaster because the town of Cordova ended up having an F4 tornado. And you can see here clearly that Cordova is not inside your warning polygon. We don't want that to happen. So let's go back and look at, say, a default 30-minute polygon. There's a couple things we want to do to correct for any issues that may come up. The first thing is we want to shrink the upstream end to correspond with the actual threat. WarnGen polygons, the default polygons, typically put some kind of buffer zone on the front end and the back end. Notice here how the back end has the same buffer zone. We'll take care of that in just a second. The second thing we want to do is flare out to both the left and the right to account for deviant motion. See how I've done here. So we've accounted especially more to the right here in case this supercell decides that it wants to turn right. The next thing we want to do is actually clip off this portion of the polygon that goes into the next county, and is also an extension beyond the 30-minute arrow that you see here. Then we can snap that polygon back to the county borders. This would be Fayette, Tuscaloosa County, as it borders along the county of Walker here, going to the northeast. Notice how different my old warning, the default warning, is compared to the new warning. So we've allowed more space on the right hand side, and we've also cut it a little bit shorter, made it 30 minutes instead of the standard 45 to account for, again, any deviant motions that this storm may have. Let's take a look at a second example. This is the famous F4 tornado from the city of Tuscaloosa. Obviously you have a nice debris ball signature here in the reflectivity, but I want you to notice that a secondary supercell has come up in the RFD section of the storm. So now we're actually dealing with two separate supercells that are really in proximity close to each other. Obviously you can see the F4 reflectivity and velocity couplet here. That's very noticeable, but notice the secondary couplet is starting to gain some strength. We have a couple options here. If we already have a polygon out, hopefully we do, for an F4 tornado going into or going across Tuscaloosa and working its way to Jefferson County, we can always introduce a new polygon. This is oftentimes going to introduce a lot of confusion to your end customers, so you certainly want to make them aware through text editing that this is for a separate circulation that's yet to come into the city of Tuscaloosa. If we didn't happen to have a warning on either one, we could enlarge the polygon to include both circulations, as you see here. A third option will actually be to use line of storms. You can see I've changed my track type over here to line of storms, and we can put vertices, centroids, on both mesocyclones. You'd want to track it the same way, placing the center again right in the middle of the mesocyclones. Then you would want to fix your polygon where it looks something like this. Again, large enough to include both of the threads. You'd also have to do a little hand editing, and you can see in this case this is actually the method that we chose to combat this problem, but we also introduced this line into the warning that says this is a separate circulation, in this case north of Tuscaloosa. So you always want to have your users informed. That takes me right to my tips section about warnings. We do have weather radio as our main dissemination tool, but remember, we have NWS chat and we have now Twitter and Facebook, other means of social media to get our message out. If you're in a situation where you need to explain yourself as far as your warnings, feel free to always use these other methods. Keep in mind too that weather radios and siren, a lot of the siren-based systems are still county-based. However, there is a segment of the population that has upgraded now to polygon-based warnings, including a lot of the media partners and people who get warnings on their PDA devices. The lowest common denominator is still going to be weather radios, so we want to remember that, and remember we're sounding them for the whole county, even though the threat is going to only be for partial areas in the county. Finally, I always want you to maintain a high situational awareness about changing conditions. Be able to think outside the box when circumstances dictate. If you have an unprecedented outbreak in your CWA, you might take unprecedented warnings to combat that situation, and remember, we're out to save life and property. If you do these things, you will be successful.